हेलो लिसनर्स। तो आज हम लोग करेंगे यूनिट एंड मेजरमेंट क्लास 11 चैप्टर 1 फिजिक्स। इंट्रोडक्शन। मेजरमेंट ऑफ एनी फिजिकल क्वांटिटी इन्वॉल्व कंपैरिजन with a certain basic or arbitrarily chosen internationally accepted reference standard called unit. The result of a measurement of a physical quantity is expressed by number or a numerical measure accompanied by a unit. Although the number of the physical quantities appear to be very large, we need only a limited number of units for the expressing all the physical quantities since they are interrelated with one another. The unit for the fundamental or the base quantities are called fundamental or the base unit. The unit of all the other physical quantities can be expressed as a combination of the base unit. Such a unit obtained for the derivatives quantities are called derivative units. A complete set of these units, both the base unit and the derived base unit, is known as the system of units. uh, Topic number 2.2: the international system of unit. In earlier times, the scientists of different countries were using different system of unit measurement and measurement. These systems, the CGS and FPS or a British system and the MKS system, were used in extensively till recently. The base unit for the length, mass, and time is the system. In these system were as follow. In CGS system, there were centimeter, grams, and second respectively. In FPS system, they were foot, pound, and second respectively. In MKS system were made kilogram and second and meter, kilogram, and seconds respectively. The system of unit which is present internationally accepted for the measurement in the system international day unite French of international of the units as abbreviated as the SIE. The SI with the standard scheme of the symbol unit and the abbreviation but development and the recommended by the General Conference on Weight on Measure in 1971 for the international uses. In the scheme, technical industries and the commercial work become the SI unit because of commercial work because SI unit used decimal systems. Conversion with the system are quite simple and convenience. We shall follow the SI unit in the books. The SI there was a seven unit are given in the table 2.1. Besides the seven base unit, there are two more unit are defined for a plane and angle and d theta as the ratio of length of RDS to the radius R, and B solid angles d omega as the ratio of the intercepted area dA of the spherical surface described about. The apex O at the center to the square of its radius R. Uh, the unit for the plane is the radian with a symbol rad, and the unit for the solid angle is stadian and with the symbol SR. Both these dimensionless quantities. And here are base quantity. And I just telling about the table. So first of all, I just tell about base quantities, names, symbols, SI unit, and definitions. Our length, name meter, symbol M, and the definition. The meter is the length of the path traveled by in light in vacuums during a time of interval 1 upon 299 299,792,458 of second, uh, full stop 1983. Mass, kilogram, kg. The kilogram is equal to the mass of the international prototype of the kilogram. A platinum iridium allow cylinder kept at the International Bureau of the Weight and Measurement at serves near Paris, France, 1889. Time, second. symbol S. The second is the duration of the 91926317770 period of the radiation corresponding to the transition between the two hyperfine level of the ground state of the cesium uh, 133 atoms in 1967. Electric current ampere, symbol A. The ampere is a constant current which is if maintained in a two straight parallel conductor to infinite length of negligible circle cross section and placed 1 meter apart in a vacuum would produce between these conductor a force equal to 2 into 7 power 10 to power minus 7 Newton per meter of the length. Thermodynamics temperature Kelvin K. The Kelvin is a fraction of 1 upon 273.16 of the thermodynamic temperature of the triple point of water. 1967. The amount of substance mole. The mole is the amount of the substance of a system which contain as many elementary entities as there are atoms in 0.0012 kilogram of carbon 12 1971. A luminous intensity candela CD. The candela is a luminous intensity in a given direction of a source that emit a monochronic radiation of the frequency 540 into 10 to power 12 hertz, and that has a radiant intensity in the direction of 1 upon 683 watt per stadion. 1979. And here some unit related for general use through outside SI system. Minute MIN, sorry, minute symbol MIN, value in SI unit. 60 second hour H. 60 minute is equal to 360, sorry, 3600 seconds. Day, symbol D, value for 24 hours 8614 years, symbol Y, 365.25 days, or second, 3.156 into 10 to power 7 seconds. Degree, symbol डिग्री का symbol ही है. 1 degree is equal to pi upon 180 into radian. और लीटर L, 1 liter is equal to 1 decameter cube is equal to 10 to power minus 3 meter cube. Tons, symbol T, 10 to power 3 kg. Carat, symbol C, 200 mg. Bar, symbol bar, value 0.1 MPa is equal to 10 to the power 5 PA. Query, symbol CI, value 3.7 into 10 to power 10 second minus power minus 1. Rotary ring, symbol R, value 2.58 into 10 to power minus 4 kilogram upon, sorry, C upon kilogram. और क्विंटल Q 100 kg. Baron B 100 FM square is equal to 10 to power minus 28 meter square. R, symbol A, 1 decameter square dam square is equal to 10 to power 2 meter square. R, symbol A, 1 dam square is equal to 10 to power 2 meter square. Hectare HA, value 1 HM square is equal to 10 to power 4 meter square. Standard atmosphere pressure ATM, value SI unit 100, sorry, 101325 PA is equal to 1.013 into 10 to the power 5 PA. Note that when the mole is used, the elementary entities must be specified. These entities may be atom, molecules, ions, electrons, other particles, or a specified group of the such particles. We employ unit for the some physical quantities that can be derived from the 7 basic unit appendix A6. Some derived unit in terms of SI unit are given in appendix A61. Some SI unit are given special names. Some special names appendix A62, and some derived unit makes use of unit with the special names and the and the 7 base unit appendix A 6.3. These are the given appendix A 6.2 and A 6.3 for the your ready reference. Other unit retained for the general use are given in table 2.2. Common SI prefix and the symbol for a multiple and the sub multiple are given in appendix A2. General guidelines for the using symbol for the physical quantities, chemical element, and the nucleates are the given in appendix A7, and those for the SI unit and some other units are given in appendix A8 for the guidance for the ready reference. Topic number 2.3, measurement of the length. You are already familiar with some direct method for the measurement of the length. For example, a meter scale is used for length for from 10 to the power minus 3 meter to 10 to the power 2 meter. Of vernier capillary is used for the length of an accuracy of 10 to the power minus 4 meter. A screw gauge and a speedometer can be used to measure length as a less as to 10 to the power minus 5 meter. To measure a length beyond these ranges, we make use of some special indirect method. Topic number 2.3.1, measurement of the large distance such as an direction distance of planet for a star from the earth cannot be measured directly with a meter or scale. As an important method in such cases is the parallax method. When you hold a pencil in front of you against the some specific point on the background of a hole, with a look at the pencil and first through you left eyes are closing the right eyes and closing the and then look at the pencil through your right eye. B, closing the left eyes, you would notice that the position of the pencil seems to change with respect to the point on the wall. This was called the parallax. The distance between the 2 points of the observation is called the basic. In the example, the basic is the distance difference between the eyes to measure the distance d of a far away planet S. By the parallax method, we observe it from two different position observation A and the B, and on the earth separation distance AB equal to B at the point same point as on we measure the angle between the two directions along the which the planet is viewed as the 2 point. The angle ASB in figure represent by the symbol theta is called the parallel angle or the parallelic angles. As the planet is very far away, B upon D greater than 1, and therefore theta is very small, then we approximately take AB as length AB as an arc of length B of a center circle and with center at S at the distance of D as the radius A as equal to BS, so that the AB equal to B equal to D theta, where D theta is a radian. D equal to B upon theta. Having determined D, we can employ a familiar method to determine the size of the angular determinant of the planet. If D is the diameter of the planet and alpha and the angular size of the planet, the angle subtended by D at the earth, we have A equal to D upon alpha equal to D upon capital D. The angle alpha can be measured. The angle alpha can be measured the same location on the earth. It can be angle between the two directions when two diametrically opposition point of the planet are viewed through the telescope. Since D is known as the diameter D of the planet can be determined using equation 2.3 बोलना नहीं तो. And here some numericals, but we don't read numericals, so just for the reading the topics and definitions. Topic number 2.3.2, Estimation of the very small distance size of a molecules to measure a very small size like that of the molecule 10 to power minus 10, 8 meter to 10 to power 10 meter. We have adopted a special method. We cannot use a gauge or a similar instrument. Even a microscope has an certain limitation and option microscope uses a visual light to look at a system under investigation. At the light has wave like features. The resolution to the which an optical microscopic can be used as a wavelength of the light. A detailed explanation in can be found in the class 12th physics textbook. For a visual light, the range of the wavelength is from the about 4000 ampere to 7000 ampere. One astrostorm is equal to 1 ampere, 1 A is equal to 10 to the power 10 meter. Hence, an optical microscope cannot resolve particles with size smaller than this. Instead of visual light, we can use an electronic beam. Electronic beam can be focused by properly designed electric and the magnetic field. The resolution of such electrons microscope is limited final by the fact that electron can be also behaved as a wave. You will learn more about this in the chapter 12. The wavelength of an electron can be as small as the fraction of an angstrom. Such electrons microscopic with the resolution of zero point 0.6 amperes, which have been built. They can be almost resolve atom and the molecule in the material. In recent times, tunneling microscopic has been developed, which again the limit of the resolution to better than the angstroms. Uh, it is possible to estimate the size of the molecule. A simple method of estimating the molecular size of oleic acid is given below. The oleic acid is a soapy liquid. The large molecule size of the order of 10 to the power minus 9 meter. The idea is to first form monomolecular layer of oleic acid of water surface. We dissolve 1 centimeter cube of oleic acid in an alcohol to make a solution of 20 centimeter cube. When then we take 1 centimeter of the solution can be diluted it to 20, 10 to say 20 power 20 centimeter cube using alcohol. So the concentration of the solution is equal to 1 upon 20 into 20 centimeter cube of the oleic acid upon centimeter square of the solution. Next, we lightly sparkle some lycopodium powder on the surface of the water in the large throw, and we can put 1 drop of the solution in the water. The oleic acid drop is spread into thin, very large and rough circular films of a molecular thickness on the wall surface. Then we quickly measure the diameter of the thin film to get it area. Suppose we have drop in the water intensely. We can determine the approximately value of each droplet v centimeter cube. Topic number 2.4: measurement of masses. Measurement of the basic property of nature. It does not depend on the temperature, pressure, or pressure or location of the object of in space. The SI unit is of this. The SI unit of the mass is the kilogram kg. The prototype of the instrument is kilogram. The prototype of the international standard kilogram supplied by the International Bureau of Weight and Measurement BIPM. are available in many other languages of different countries. In India, this is available at the National Physics Laboratory (NPL), New Delhi. While doing while dealing with the atoms and molecules, the kilograms is an inconvenient unit. In this case, there is an important standard unit of mass called the Unified Atomic Mass Unit, which has established for the expressing the mass as one untitled atomic mass equal to 1 mu equal to 1 upon 12th of the mass of the atom of carbon. Isotopes 12c, sorry, 60, including the mass of the electrons is equal to 1.66 key power 6 into 10 to the power minus 27 kilograms. Mass of the commonly available object can be determined by a common balance, can be determined by the common balance like the one used in the grocery and large grocery shop grocery sorry grocery shops. Large masses in the universe like plant plant सॉरी यहाँ पे थोड़ा गड़बड़ हो गया. Plant starts etc based on the Newton's law of gravitation can be measured by the gravitational method. See chapter 10. See chapter See chapter 8 for the measurement of small masses of atoms, sub small particles etc. We can use the mass of the spectrograph in which radius of the trajectory in proportion of the masses of the charged particles moving in a uniform electric and magnetic field. Topic number 2.4.1, range of the masses. The masses of one object we can come across in the universe vary over a wide range. These may vary from the tiny masses of the order of 10 to the power minus 13 kilograms of an electron of the huge masses of about 10 to the power 13 kilograms, 10 to the power 55 kilograms of the universe. Table 2.4 gives the range of the order to typical masses various objects. Size of the distance length in meter. Size of the proton 10 to the power minus 15. Size of the atomic nucleus 10 to the power minus 14. Size of the hydrogen atom 10 to the power minus 10. Length of the typical virus 10 to the power minus 8. Wavelength of the light 10 to the power minus 7. Size of the red blood capsules 10 to the power minus 5. Or thickness of the paper 10 to the power minus 14. Height of the Mount Everest sea level 10 to the power minus 4. Radius of the earth 10 to the power 7. Distance from the sun 10 to the power 8. Distance from the moon, sorry, distance from the sun 10 to the power 8, and distance from the moon 10 to the power 8. Or distance from the sun 10 to the power 11. Distance from the Pluto from the sun 10 to the power 13. Size of the galaxy 10 to the power 21. Distance of the Andromeda galaxy 10 to the power 23. Distance of the Landry observer in the universe 10 to the power 26. Table number 2.4, range and other order of masses. Uh, Object and masses: electron 10 to the power minus 13, proton 10 to the power minus 27. Period of X-ray 10 to the power. Uranium atom 10 to the power minus 25. Red blood cells 10 to the power minus 13. Dark particles, dust particles 10 to the power minus 9. Raindrop का होता है 10 to the power minus 6. और रेन ड्रॉप होता है 10 to the power minus 6. मॉस्किटो होता है 10 to the power 0.5. ग्राफ्स होते हैं 10 to the power 0.3. ह्यूमंस होते हैं 10 to the power 2. ऑटोमोबाइल्स होते हैं 10 to the power 3. बी बोइंग 747 एयरक्राफ्ट 10 to the power 8. मून होता है 10 to the power 23. अर्थ होता है 10 to the power 25. सन होता है 10 to the power 13. मिल्की वे गैलेक्सी हुई 10 to the power 14, सॉरी 10 to the power 41. यूनिवर्सल सॉरी ऑब्जर्वेबल यूनिवर्स होता है 10 to the power 55. टॉपिक नंबर 2.5, मेजरमेंट ऑफ द टाइम. To measure any interval of time we need a clock. To measure any sorry we now use a atomic standard of time, which is based on the periodic vibrations produced in the cesium atom. This is based on the cesium clock, sometimes called the atomic clock, used in the national standard. Such standard are available in the many laboratories. In the cesium atomic clock, the second is taken as the time needed for the 919263770 vibrations of the radiation, corresponding to the transitional between the hyperfine level of the ground state of cesium 133 atoms. The vibration of the cesium atom regulates the rate of the cesium atom, just as the vibration of a balance wheel regulate an ordinary wristwatch. Of the vibration on a small quench crystal regulate quench wristwatch. The cesium atomic clock was very accurate in a principle. They provide a profitable standard, the national standard of a time interval second, as the frequency is maintained through the from the cesium atomic clocks. A cesium atomic clock is used at the National Physical Laboratory (NPL), New Delhi, to maintain the Indian Standard of Time. In our country, the NPL has a responsibility of maintain and improvement of the physical standard, including that of time, frequency, etc. Note that the Indian Standard Time (IST) is linked to the set of atomic clock. The efficient cesium atomic clocks are so accurate that they are imparted certainly in these resolutions as plus minus 1 into 10 to the power minus 13, i.e. one part is 10 to the power 13. This implies that the uncertainty gained over time by such devices is less than one part of the 10 to the power 13. They lose or gain no more than 13 new s is in 1 year. In view the tremendous accuracy in the time measurement, the SI unit of the length has been exposed in terms of the path length weight travel in certain interval of time 1 upon 29 1 upon 299,792,458 of a second. Table 2.1. The time interval of the event that can become across the universe vary over a very wide ranging. Travel 2.5 gives the range order of the typical time interval. You may notice that there is an interesting coincidence between the number of appearing in table 2.3 and 2.5. Note that the ratio of the longest and shortest table of object in our universe is about 20 to the power 41. Interestingly enough, the ratio longest and shortest interval associated with the event and the object in our about 10 to the power 41. The number of the this number 10 to the power 41 comes again in the table 2.4, which lists the largest typical mass of the object. The ratio of the largest and the smallest of the object in our universe is about 10 to the power 41 key bracket key power 2. In this curious coincidence between the focus between these large number purely accidental. Topic number 2.6, accuracy, precision of the instrument and errors in a measurement. Measurement is the fundamental of the all experiment, science and technology. The result of the every measurement of any a measuring instrument contains some uncertainty. This uncertainty are called the error. Every calculation quantity which is based on the measure values also has an error. We shall distinguish between the two term accuracy and precision. The accuracy of the measurement is a measure of the how close measured value is to the true value of the quantity. Precision tell us to what resolution or the limit the quantity is measured. The accuracy is the measured may depend on the several factors, including the limit of the resolution of the measuring instrument. For example, suppose a travel value of a certain length is near to 3.678 centimeter of in one experiment using a measuring instrument of the resolution 0.1. The measure value is found to be 3.5 meter, while another experiment using the measuring the greater resolution may say 0.01 centimeter. The length of the determined to be 3.38 centimeter. The first measurement has the more accuracy because it is event and time interval range and the order of the time interval. Lifespan of the most unstable particle 10 to the minus 24. Time required for the light to cross a nuclear distance 10 to the minus 22. Periodic of X-ray 10 to the minus 19. Period of the atomic variation 10 to the minus 15. Period of the light wave 10 to the minus 15. Life time of the excited state of an atom 10 to the minus 8. Period of the radio wave is equal to 10 to the power minus 6. Periodic of the sound wave is equal to 10 to the power minus 3. Wink of ice is 10 to the power minus 1. Time between successive human heartbeat 10 to the power minus 0. Travel time for the light from the sun to the earth 10 to power 0. यहाँ पे 10 डिग्री लिखा है यहाँ पे शायद. Travel time for the light from the sun earth 10 to power 2. Time period of the satellite 10 to power 4. Rotation of the period of the earth 10 to power 5. Rotation of the revolution period of the moon 10 to power 6. Revolution of the period of the earth 10 to power 7. Travel time of the light from the nearest star 10 to power 8. Average human lifespan 10 to power 9. Age of the Egyptian pyramid 10 to power 11. Time since the dinosaur because extinction 10 to power 15. Age of the universe 10 to power 17. Closer to the true value but less precision. That resolution is only 0.1 centimeter, while the second measurement is less accurate but more precise. Thus, every measurement is approx due to errors in the measurement. In the general, error in the measurement can be broadly classified as a systematic erosion, sorry, error, and B, random errors. Systematic errors. The systematic error are those that tend to be in the one direction, either positive or negative. Some of the source of the systematic errors are A, instrumental errors that arise from the error due to the imperfect design or collaboration to the of the measurement instrument. Zero errors in the instrument etc. For example, the temperature graduation of the thermometer may be inadequately calibrated. It may read 104 degrees centigrade at the boiling point of water at STP, whereas it should read 10 to 100 degrees centigrade in a vernier calibration of the zero mark of the vernier scale may not conclude that the zero mark of the main scale or simply or ordinary meter scale may be born off at one end. B. Imperfection in experiment technique or producer to describe the temperature of the human body. A thermometer placed under the armpit will always give a temperature lower than the actual body temperature. Other external conditions such as change in temperature, humidity, wind velocity, etc. During the experiment may systematic affect the measurement. See personal errors that arise due to an individual basis lack of the proper setting of the aperture of the individual's carelessness in the taking observation without observing proper precaution etc. For example, if you by habit always hold your head on a bit far to the right while reading the position of the needle on a scale, you can introduce an error due to parallax. Systematic erosion and can be minimized by the improving experiment techniques, selecting a better instrument and removing personal biases as for the possible for a given setup. These errors may be estimated to certain extent and the necessary correction may be applied to the reading. Random errors, the random error are those which occur irregularly and hence are the random and with respect to sign and size. These can be arise due to the random and unpredictable fluctuation in experiment condition. Example, unpredictable fluctuations in the temperature, volatile supply of the mechanism, variations of the experiment setup, etc. Personal unbiased errors by the observers taken. Reading etc. For example, when the same person repeats the same observation, it is very likely that he may get different reading every time. Least count errors. The smallest value that can be measured by the measuring instrument is called the least count. Least count. All the readings to or measured value are good only up to the value. The least count value errors is the error associated with the resolution of the instrument. For example, a vernier capillaries has been last count 0.01 centimeter. A speedometer may have a belong to category random errors, but systematic and the random errors systematic and the random error. If we use a meter scale for the measurement of the length, it may have graduations at 1.1 millimeter division scale spacing or interval. Using instrument of the higher precision, improving experiment technique, etc., we can reduce the least count errors, repeated the observation of several times, and taking arithmetic means of the all observation. The mean value of would be the very close of to the true value of measurement quantity. Here we just leave the topic number 2.6.1, absolute errors, relative errors, and the percentage error. I hope just you just read this chapter through books because it's topic. This topic is containing too much numericals. That is not, I think, no part for our reading sessions. So, topic number 2.6.2, combination of the error. If we do an experiment involving several measurements, we must know how the errors in a simple measurement combine. For example, a, the errors of a sum or a difference. Suppose two physical quantities A and B have the measurement value A plus minus triangle A, B plus minus A, plus minus and triangle B respectively, where triangle A and triangle B are their absolute errors. We wish to find the error A, triangle Z in the sum Z is equal to A plus B. We have by addition Z plus minus triangle Z, A plus minus triangle A plus B plus minus triangle B. The maximum possible errors in Z, triangle Z is equal to triangle A plus triangle B. For difference Z is equal to A minus B, we have Z plus minus triangle Z is equal to A plus triangle A plus A plus minus a triangle A minus B plus minus triangle B is equal to A minus B plus minus a triangle A plus minus a B, or triangle Z is equal to plus minus a triangle A plus minus B. The maximum value of the error triangle Z is again triangle A plus triangle B. Hence the rule: when two quantities are the added or subtracted, the absolute error in the final result in the sum of the absolute errors in the individual quantities. B. Error of the product of the quotient. Suppose Z is equal to AB and the measured value of A and B are the A plus minus triangle triangle A B plus minus triangle B, then Z is plus minus triangle Z is equal to A plus minus triangle A, B plus minus a triangle B is equal to AB plus minus B plus triangle A plus minus triangle A plus triangle B plus minus triangle A into triangle B, dividing LHS by Z and RHS by AB. We have plus 1 plus minus into triangle Z upon Z is equal to 1 plus minus triangle A upon 8 plus minus triangle B upon B plus minus triangle A upon A into triangle B upon B. Since triangle A and triangle B are small, we shall ignore their product. Hence, the maximum relative errors triangle Z upon Z is equal to triangle A upon A plus triangle B plus upon B. You can easily verify that this is true for division also. Hence, the rule when two quantities are multiplied or divided, the relative error in the result is the sum of the relative error in the result is the sum of the relative error is the multiplier. And here are very examples of questions and numericals of the physics, and we just don't include these numericals in our question series. C. Error in the case of the measuring quantities rise to the power. Suppose Z is equal to A square. Then triangle Z upon Z is equal to triangle A upon A plus triangle A upon A is equal to 2 into triangle A upon A. Hence, the relative error in the A square is 2 times the error in A. In general, if Z is equal to P and B Q upon C R, then triangle Z upon Z is equal to P into triangle A upon A plus the triangle Q into triangle B upon B plus R into triangle C upon C. Hence, the rule: the relative error in a physical quantity raised to power k is the k times at the relative error in the individual quantity. Topic number 2.7, significant figures. As discussed above, every movement involved errors. Thus, the result of the measurement should be reported in a way that indicate a precision of the measurement. Normally, the report result of the measurement is a number that include all the digits in a number are that are relatively reliably plus the first digit that the uncertain, the reliable digit first. Plus, in the first uncertain digits are known as significant digit or a significant figure. If we can say the period of the oscillation of a simple pendulum is 1.62 seconds, the digit of 1 and the 6 are the reliable and are certain, while the digit of 2 uncertain. Thus, the measurement value has three significant figures. The length of an object reported after measurement to be 287.5 centimeter has the four significant digit 287 are the certain, while that 5 digit is uncertain. Clearly reported the result of the measurement that included more digit. That significant digit is superfluous and also misleading, since it would be given a wrong idea that precision of the measurement. The rule of the determining the number of the significant figure can be understood from the following example. Significant figures indicate, as is already mentioned, the precision of the measurement, which depend on the least count of the measuring instrument. A choice of the change of different unit does not change the number of the significant digit or the figure in a measurement. The important remark makes the most of the following observation clear. First, for example, the length of the 2.308 centimeter has four significant figure, but the different unit same value can be written as 0.02308 or meter, or 23.08 millimeter, or 23080 new meter. All these numbers have the same number of significant figure digit 2308, namely 4. This shown that the location of the decimal point is no consequential in the determination the number of the significant figure. The example gives the following rules. All the non-zero digit are the significant. All the zero between the two non-zero digit are the significant figures, no matter where the decimal point is, if at all. If the number is less than 1, the zeros on the right of the decimal point but to the left to the first non-zero digit are the significant. In 0.002308, the underlined are the not significant. The terminal of the training zero in number without a decimal pointing are not significant. Thus, 123 meter is equal to 12300 centimeter is equal to 123 000 millimeter has a three significant figure. The training zeros as being not significant. However, you can also see the observation. The trailing zero in a number with a decimal point significant. The number 3500 or 0.069000 have a four significant figure each. Second, there can be some confusion regarding the trailing zeros. Suppose a length is reported to be 4.700 meter. It is event that the zeros here are meant to convey the precision of the measurement and are therefore significance. If these were not, it would be superficial to write them explicitly. The report measurement would have been simply 4.7 meter. Now suppose that we change the unit, then for 700 meter is equal to 470.0 centimeter is equal to 4700 millimeter is equal to 0.004700 kilometer. Since the last number has trailing zeros in a number with no decimal, we would conclude anonymously from the observation 1 from above that the number has significant figures, while fact it has a significant figure, and a mere change of the unit cannot change the number of the significant figure. Third, to remove such ambiguities in the determination the number of the significant figure, the best way to report every measurement in scientific notation in the power of 10. In the rotation, every number is expressed as a into 10 to power b, where a is the number between the a and b is any positive or the negative exponent of the power of the 10. In order to get any approximate idea of the number, we can may round off the number of number a to 1 for greater than 5, and 10 for the 5 a greater than a greater than 10. Then the number can be expressed approximately as 10 to power b, in which exponent or the power b of 10 is called order of the magnitude of the physical quantities. When only as estimated is required, the quantity is of the order of 10 to power b. For example, the diameter of the earth 1.28 into 10 to power 7 meter is the order of the 10 to power 7 meter with the order 2 of magnitude 7. The diameter of the hydrogen atoms 1.06 into 10 to power minus 10 meters is the order of 10 to power minus 10 meter within the order of the magnitude 10 minus 10. Thus the diameter of the earth is 17 order of the magnitude larger than the hydrogen atom. It is often compulsory to write the decimal after the first digit. Now confusion mentioned in A above that disappears to for 4.700 meter is equal to 4.700 into 10 to power centimeter 10 to power 2 centimeter is equal to 4.700 into 10 to power 3 millimeter is equal to 4.700 into 10 to power minus 3 kilometer. The power of the 10 is irrelevant to the determination of the significant figure. However, all the zeros appear in the base number in the scientific notation and the are significant. Each number in the case has four significant figures. Thus, in the scientific notation, no confusion arises about the trailing zeros in the base number a. They are always significant. For the significant notation is the ideal for the reporting measurement. But if this is not adopted, we use the rule adopted in the precision example. For a number greater than 1 without any decimal, the trailing zeros are the not significant. For a number with a decimal, the trailing zeros are the significant. Fifth, the digit 0 conventionally put the left of a decimal. For a number less than 1, like 0.1250 is a negative significant. However, the 0 at the end of the such number are the significant in the measurement. Sixth, the multiplying or dividing factor, which are the neither round number nor number represent measure the value or exact the have an infinite number or the of significant digit. For example, in r is equal to d upon 2 or the s is equal to 2 pi r, the factor 2 is an exact number and it cannot be written as a 2.00 or 2.000000 as recorded. Similarly, in t is equal to t upon n is the exact number. Topic number 2.7.1, the rule of the arithmetic operation with the significant figures. The result of the calculation involving approximate measure the value of the quantities, i.e., values with the limitation number of the significant figure must reflect the uncertainty in the original measurement value. It cannot be more accurate than the measured value themselves on the which the result is based. In general, the final result should be have more significant figure than the original data from which is obtained. Thus, if the mass of an object is measured to be say 4.237 gram for significant figure and its volume is measured to be 2.51 centimeter cube, then the density by the arithmetic division is 1.68804780.876 gram centimeter cube up to 11 decimal places. It would be clearly observed the irrelevant to record the calculation value of the density to such a precision when the measurement on which the value is based have much less precision. The The following rule for the arithmetic operation with a significant figure to ensure that the final result of a calculation is shown the precision that is consistent with the precision of the income measured value. One multiplication or the division, the final result should retain as a number as many significant figure as are there is a an original number with a least significant figures. Thus, in example, absolute density should be reported to three significant figures. Density is equal to 4.237 grams upon 2.51 centimeter cube is equal to 1.69 gram centimeter cube minus cube. Similarly, in the speed of the light is given as a 10 to 3.00 into 10 to the power 8 meter second minus cube. Three significant and the 1 year is equal to 1 year is equal to 365.225 days. Days has सॉरी डेज नहीं है डी है यहाँ पे हैज़ 3.155 इंटू 10 to the power 7 second 5 significant figures the light year is 9.47 into 10 to the power 15 meter the three significant figures second additional of the subtract on the final result should retain as many decimal places are there as R there is a number with the least decimal places. For example, the sum of the numbers 436.32 gram to 7.2 grams and 0.0301 grams by the mere arithmetic addition is 663.8321 gram, but the least precious measurement 2 to 7.2 grams is correct into only one decimal place. The final result should be therefore be rounded off the 6.663.8 grams. Similarly, the difference is the length can be expressed as 0.307 meter minus 0.304 meter is equal to 0.003 meter is equal to 3 into 10 to the power minus 3 meter. Note that we should not use the rule 1 applicable for the multiplication and division and the desired 6.64 grams as a result in example of the addition and 3.00 into 10 to the power minus 3 is a meter is an example of the subtraction. They not be convey the precision of the measurement properly for addition and subtraction. The rule is the term of decimal precision. Topic number 2.7.2, the rounding of the uncertain digits. The result of the computing and the approximate number which contain more than uncertain digit of the should be round of the rules of the rounding of the rule do not to the appropriate significant figure are obvious. The most cases number 2.46. Now 6 is underlined rounding of the two three significant figures 2.75 while the number 2.74743 would be 2.74. The rule by convention is that the preceding digit is released by 1 if the insignificant digit to be dropped. Underlined digit in the case is more than 5 is left unchanged. If the letter is less than 5, what if the number is 2.745 and 5 is underlined is which is a significant insignificant digit is under 5. Here the convention if is that if the precision digit is the even the insignificant digit is simply dropped, and if the odd preceding digit is reached by 1, then the number 2.745 rounded off the significant figure become 2.74. On the other hand, the number on the hand number 2.735 rounding off the two three significant figures become 2.74 since the presiding digit is odd. In any involvement of the complex multi-step calculations, you should retain in intermediaries step one digit more than the significant digit and round off to the proper significant figure at the end of the calculation. Similarly, a number of no to the within the many significant figures such as 2.9979245 into 10 to the power 8 meter second. For the speed of the light vacuum is rounding off of an approximate value 3 into 10 to the power 8 meter second, which is often employed in computation. Finally, remember the exact value of that appear in the formula like 2 pi in t to sorry in t is equal to 2 pi under root L upon G. Have a large infinite number to significant figure. The value of pi is equal to 3.1415192 is known as the largest number of the significant figure. You can maybe value as a 3.142 or 3.14 for the pi with limited number of the significant figure are required in a specific case. Topic number 2.7.3 Rules for the determining the uncertainty in a result of the arithmetic calculation. The rule of the determination the uncertainty in or error in the number upon measured quantity in the arithmetic operations can be understood from the following experiment. First, if the if the length and width of the thin regular rectangular sheet are measured using a meter scale 16.2 and 10.1 centimeter respectively, there are the three significant figures in the each measurement. It is a length L may be written as L is equal to 16.2 plus minus 0.1 centimeter is equal to 16.2 centimeter plus minus 1 to plus minus 0.6 percent. Similarly, the breadth B can written as B is equal to 10 to the power minus 1 and plus minus 0.1 centimeter, 10 to the power minus 1 centimeter plus minus 1 plus minus 1%. Then the error produced of two or more experiment, the value using the combination of the error rules will be 1 b is equal to 163.62 32 centimeter cube plus minus plus square plus minus 1.6% is equal to 163.62 plus minus 2.6 centimeter square. This leads us to quote the final result as the LB is equal to 164 plus minus 3 centimeter square. Here 3 centimeter square is uncertainty or error in the estimation of the area of rectangular sheets. Second, if a set of experiment data are specified to a significant figure, a result obtained by a combining the data will be valid of significant figure. However, if data are subtracted, the number of significant figure can be reduced. For example, 112.9 minus 7.06 gram, but the both associated significant figures cannot be properly be evaluated as 5.84 gram, but only as the 0.58 as uncertainty in the subtraction or addition. The combined in different fashion the smallest number of the decimal places rather than the number of the significant figure in any of the number added to the or subtracted. 3. The relative error of the value of a number specified to a significant figure depend not only on the n but also on the number itself. For example, the accuracy in the measurement of the mass 1.02 gram is 0 plus minus 0.1 gram, whereas another measurement 9.89 gram is accurate to plus minus 0.01 gram. This relatively error in 1.02 grams is equal to plus minus 0.1 upon 1.0.2 into 10 to the power 100%. Similarly, the relative error in 9.89 gram is equal to plus minus 0.1 upon 9.89 into 10 to the power 11% is equal to plus minus 0.1%. Finally, remember the intermediate result is in multi-step computation should be calculated to one more significant figure every mensuration than the number of digits in the least precision measure. These first should be justified by the data, and then arithmetic operation may be carried out. The otherwise rounding the other but can bolt up for the example. The reciprocal of the 9.58 calculated after rounding of the same value number of a significant figure figure 3 is 0.104, but the reciprocal of 0.104 calculated as a three-significant figure 9.62. However, if we retain as 1 upon 9.58 is equal to 0.1044, and then taking reciprocal to the c significant figure, we would having retrieved the original value of 9.58. The three in the this example justify the idea of retain one more extra digit, that the number of the digit in the least precision measurement in intermediate step of the complex multi-step calculations in the order to avoid additional errors in the process of the rounding of the numbers. Topic number 2.8, dimensional of the physical quantities. The nature of the physical quantity is described by the dimension of the physical quantities as represented by the derived unit can be expressed in term of the sum combination of the seven fundamental of the base quantities. We can these base quantities as seven dimensions of the physical world, which are denoted with the square bracket. Thus the length has the dimension L, mass M, time T, the electric current A, thermodynamics temperature K, luminous intensity CD, the amount of the substance mole. The dimensions of the physical quantities are the power of the exponent of to which the base quantity are released to represent that the quantity. Note that the using of the square bracket around quantity does not we dealing with the dimension of the quantities in mechanics. Physical quantities can be written in the term of the dimensions. L, M, and T are the example of the volume occupied by the object is expressed as a product of the length, breadth, and height, or three element. Hence, the dimensions of the volume are the L into L cube is equal to L cube. As the volume is independent of the mass and time, it is said to possess zero dimensions. In the mass, M is uh, zero dimension in three times zero and three dimension in the length. Similarly, force as the product of the mass and the acceleration can be expressed as a force is equal to mass into acceleration, mass into length upon time square. The dimension of the force are m into L upon T square is equal to MLT Pakki power 2. Thus, the force has been one dimension in mass, one dimension in the length, and the minus two dimension or in time the dimension in after all the vast quantities. The zero, note that in this type is represented the magnitude and not considered it is the quantity of the type of the physical quantity that enter. Thus a change in the velocity, initial velocity, average velocity, final velocity, and the speed are the all equivalent in the context, since all these quantities can be expressed as a length upon time. The three their dimension are L upon T or L T minus T power minus 1. 2.9, topic number the dimensional formula and the dimensional equation. The expression which show how of and which of the base quantity represent the dimension of the physical quantity is called the dimension formula of the given physical quantity. For example, the dimensional formula of the volume is the m की power 0, l की power 3, t की power 0, and that the speed of velocity 10 to power 0 and l t की power minus t की power 1, sorry, t की power minus 1. Similarly, m0 l0 t की power minus 2 is dimension formula of the equation, and the m into 10 की power minus 3 t power 0 that of the mass density as the equation obtained by equation of physical quantity, where the dimension formula is called the dimension equation of the physical quantities. Thus, a dimension equation are the equations which represent the dimension of the physical quantity in the term of the base of the quantity. For example, the equation of volume V, speed V, force of F, and the mass density uh, P may be expressed as V is equal to v is equal to m की power 0 l की power 3 t की into 10 to power 0 small v is equal to m की power 0 l t की power minus 1 f is equal to m into l into t की power minus 2 p is equal to m into l in की power minus 3 t is equal to 0. The dimension equation can be obtained from the equation representing the relation between the physical quantities, the dimension formula of the large number, and the equation, and the a wide variety of physical quantity derived from the equation representing the relationship among the other physical quantity and exposed in terms of the various quantities are given in the appendix 6 for your guidance on ready reference. Topic number 2.10, dimension analysis and application is the recognition of the concept of the dimension which guided the description of the physical behavior of which is important as the only the physical quantities can be added or subtracted which have been the same direction. A thorough understanding of dimension analysis help us in deducing certain relation among the different physical quantities and checking the derivation accuracy of the dimension, consistency, homogeneity of various mathematical expressions. When magnitude of the two or more physical quantities are multiplied, unit. Their unit should be treated in the same manner as the ordinary algebraic symbols. We can identify the unit in the numerator of physical quantity. Similar physical quantity represented by the symbol on both sides of the mathematical equation must the same dimension. Topic number 2.10.1, checking the dimension consistency of equation. Checking the dimensional constancy of equation, the magnitude of the physical quantities may be added together or subtracted from one another only if they have a same dimension. In other words, we can add or subtract similar physical quantities. Thus, velocity cannot be added to the force, or an electric current cannot be subtracted from the thermodynamics temperature. This is simple principle called the principle of the homogeneity of the dimension in an equation is extremely useful in checking the correctness of an equation. If the dimension of all the terms are not the same, equation is wrong. Hence, if we drive an expression for length of or distance of an object regardless of the symbol appearing in the original mathematical relation, when all the individual dimension are the simplified, the remaining dimension must be that of the length. Similarly, if we drive an equation of the speed, the dimension of the on both sides of the equation when simplified must be length time, or the lt to power minus 1 dimension, are customary used as a preliminary test of the consistency of the equation where there is some doubt about the correctness of the equation. However, the dimension consistency does not guarantee its correct equation. In the uncertainty to the extent of the dimensions, quantities, or function, the argument of special functions such as a trigonometric, liotometric, log arithmetic and the exponential function must be dimensionless. A pure number of ratio of similar physical quantities such as angle as a ratio, length upon length, refractive index as a ratio, spend of the time, light in the vacuum upon speed of the light and medium, etc. has no dimensions. Now we can test the dimensional consistency or homogeneity. The equation for a distance x travel, सॉरी यहाँ पे थोड़ा बता रहे हैं एक्स इक्वल टू एक्स पावर जीरो प्लस स्पीड वी स्मॉल वी की पावर जीरो इंटू टी प्लस 1/2 for the distance x traveled a particle of or body in time t, which start from the position x0 with the initial velocity v0, small v0 at the time t is equal to 0, and the uniform acceleration a is equal to alongside the direction of the motion. The dimension of the each term may be written as x is equal to l, x0 is equal to l, and t is equal t v into t is equal to l into t 1 minus 1 t is equal to l. 1/2 at square is equal to lt square, lt minus q power minus 2 into t2 equal to L H at as each term of the right hand side of this equation has been some dimension, namely that the length which is the same as the dimension left hand side of the equation. Hence, this equation is dimensionally correct. It is may be noted that the test consistency dimension tell us no more about no less than test consistency unit, what has a advantage that we need not comment ourselves to particular choice of the unit, and we not worry about the conversion among the multiply and the sum multiply of the unit. It may be borne in mind that if equation falls in the consistency test, it is proved wrong. If it passes, it is not provided right. Thus, the dimensionally correct equation need not be actually an exact correct equation, but dimensionally wrong incorrect equation must be wrong. एंड इधर से हमारे क्वेश्चन आंसर स्टार्ट वो न्यूमेरिकल स्टार्ट हो रहे हैं, तो हम लोग इस वजह से इन्हें नहीं पढ़ेंगे। टॉपिक नंबर 2.10.2 डिड्यूसिंग रिलेशन among the physical quantity. The method of the dimension can be sometimes be used to reduce the relation among the physical quantities. For this, we should know the dependence of the physical quantity on other quantities up to the three physical quantities or the linear independence variable, and considerable it as a product type of the dependence. Let us take an example. Sorry, we just don't take an example. Sorry, मैंने गलत बोल दिया। और बस यहीं पे हमारा आई थिंक ख़त्म हो जाना चाहिए, क्योंकि यहाँ पे सब एग्जांपल दिया, तो मैं एग्जांपल बताने ही वाला हूँ, क्योंकि फिजिक्स में और ऑडियो बुक में एग्जांपल्स नॉट गुड। सो डायमेंशन एनालिसिस इज वेरी यूजफुल इन डिस्क्रीटिंग रिलेशन अमंग द इंडिपेंडेंट independent interdependent physical quantities. However, the dimensionless constant cannot be obtained by this method. This method of the dimension can only test by the dimension validity, but not the exact relationship between the physical quantities. In any equation, it does not distinguish between the physical quantities having the same dimensions. A number of exercises at the end of this chapter will be help you to develop a skill in dimensional analysis. Our chapter is completed now. Class 11, chapter 1.